Okay, what we're going to look at here is solving equations with fractions. So they're probably easier than you think. All right. So when we're solving equations, we have to undo what's been done. Okay, to get back to just the variable, the x or the y, that's on its own, and so it's on its own. So all we're doing is we're undoing things, so we're working in reverse. So I've got in my first example, x divided by 8 equals minus 2. So I need to undo this divide by 8, and the way we do that is we times by 8. Do it on both sides, and that means you're going to be left with the x on its own on the left-hand side, and then 8 times minus 2 is minus 16, and that's your answer. Okay, so when it's nice and simple like this, all we need to do is undo what's going on with the divide. So looking at the second example, I've got x divided by 4 equals 12. Well, to get back to what x was, I just need to times by 4. So I times by 4 on both sides. And I get left with x, and I get x equals 48. Okay, so nice and straightforward here. Sometimes they make it look harder than it is, so they might throw a decimal number in there. So I just carry on doing exactly what I've done before, okay? Because this is the nice simple one where it's just a fraction on its own and you're just dividing by a number. So a number, x, divided by 3 equals 1.5. So I need to undo this divide by 3 by timesing by 3 on both sides. I'm going to be left with x. So I want 3 lots of 1.5. Well, you can do it with a list, or you can do 3 lots of 1 is 3, 3 lots of 0.5 is 1.5, 3 plus 1.5 is 4.5. Okay, so all we're doing is multiplying 1.5 by 3, and there we get our solution. Okay, so sometimes when we get a fraction, though, we've got x divided by 9 equals a fraction. It equals 2/3. Again, I want to undo this divide by 9, so I'm going to times by 9 on both sides. Okay, so I've got to do x equals 9 times 2/3. So x equals 9 times 2/3. Well, when you're multiplying a whole number with a fraction, you just multiply the whole number with the number that's on the top. Remember, 9 is the same as 9 divided by 1. So when you're multiplying fractions, you multiply numerators and you multiply denominators. So 9 times 2 is 18, 1 times 3 is 3, and I can simplify this. 18 divided by 3 is 6. So the answer is x equals 6. So what I did there was, let's just recap, I times by 9. So I had 9 times 2/3, but 9 can be written as 9 divided by 1. And when we multiply fractions, we multiply the numerator to get 18, and we multiply the denominator to get 3. But the nice thing is about this fraction is 18 divided by 3 is equal to 6. So it's a whole number answer. Right, E, let's have a look at example E. So I've got 4x divided by 7 equals 8. So this time I'm going to have to do this in 2 steps. I'm going to undo this times by 7, this divide by 7, by timesing by 7 on both sides. So that's going to leave me 4x on the top. 7 times 8 is 56. Now I only want 1x, I don't want these 4x, so I'm going to have to divide by 4 on both sides. Remember, I'm undoing a times, so I must divide. So I'm left with x equals 56 divided by 4 is 14. And that is your answer. If you're not sure what the answer is, I would do a bus stop method to work that out. Okay, 4's into 5 is 1, with 1 carried over. So that leaves me 16. 4's into 16 is 4. So that's where we get the 14 from. Okay, example F. This time it's a two-step, but it's not a, whereas I had 4x on the top, it's an x minus 7 on the top. So the first thing to do, because this is one whole fraction on the left-hand side, okay, I need to undo this fraction bit. So I'm going to times by 5 on both sides. Because each fractional question is slightly different in some way. Okay, so I'm going to start by timesing by 5. I get x minus 7. 5 times 20 is 100. But I don't want x minus 7, I want x on its own. So how do I undo a minus 7? I add 7. And I do that to both sides. 100 plus 7 is 107. So x equals 107. Right, last example for you, and then maybe you can have a go at a few of these questions on your own. So I've got x divided by 7, then I'm plussing 11 equals 14. So let's just go through the steps that I do on the left-hand side. First of all, I divide by 7, then I add 11. Okay, so I need to work in reverse. The last thing I did was add 11. So I'm going to subtract 11 first from both sides. That leaves me with the x over 7, x divided by 7, and if I take 11 away from 14, I get 3. Now I've just got the fractional bit on its own. Once it's on its own, I can just times by the number that's on the bottom, the denominator, and I should be left with just x. So I'm going to times by 7 on both sides. 7 times 3 is 21, so x should be equal to 21. And there's a nice way to do this check. I'm going to replace this x by the number 21, because they're telling me that x has to equal 21. So this is where I'm going to check it. I'm going to do 21 divided by 7 plus 11, and hopefully this answer is 14. So 21 divided by 7, how many 7s into 21? That's 3. 3 plus 11 is 14, and that's the number they told me it was equal to. So yeah, tick, tick, tick. So that was my check there. So if you're never sure whether you got the right answer, your check is to put your x number back into your equation that you started with, and hopefully you get the number that they said you had. All right. Right, that's it. That's your examples. So crack on, have a go at some questions, and I will speak to you soon.